I believe some of you might have heard about schedulers, scheduling the thing, right? In our daily life also we need a schedule. There is a trigger needed. To start our daily life, we need a trigger, right? Early morning alarm. Same. So to start the loads, we need the triggers. That is called as a scheduling. Scheduling is a fundamental data warehousing concept. So there are a lot of tools available in the market for schedulers. You know, you see some tools like DAC, Autosys, Crantab, Control M. These are the different vendors. They are the different vendors. Autosys is a vendor, and Crantab is also a local to the Unix. Control M is a separate company. DAC is from the Oracle. So a lot of scheduling tools are available in the market. What do we do? What do we do? You know, say how the scheduling is working. Okay, let me take like this. So I wanted to delete a, say for example, there is a table called customer table. So I have a customer ID, customer name. Let's take only 2 columns. Okay, my file is available at 2 a.m. for example. At 2 a.m. I need to read the file and put it into the customer table. Okay, so you create a snow pipe, that is fine. But say at the same time, assume that there are one record A and B. Okay, so at 2 a.m. or 3 a.m. you wanted to truncate the table, for example. That is the one of the SQL operation. So due to some business reason, you wanted to truncate it. So you need to run your truncate statement. You need to run your truncate statement at 2 a.m. right? So you should give a scheduler for this. Okay, you will create one scheduler. Say you create one scheduler, and to the scheduler you say this statement. So then scheduler will do that. For example, you wanted to run these kind of statements. Say assume that customer is a table, and product is a table. Say region is a table. These 3 tables you wanted to truncate at same time. Okay. So and say region is a table. So now what is the scenario? You need to run these 3 statements. What do? You put it in one file. Say for example run.sql. You run this file at 2 a.m. This is the way you will be following. So yesterday we have written one Python program, right? Okay, we have written one Python program for various acts. You want to run this Python program say at 3 a.m. You attach this Python program to the scheduler, and at 3 a.m. this Python program will run. So whatever the program it wanted to be run, it would be executed at 3 a.m. Right. So these scheduling activities are carried out by the Snowflake using tasks. So tasks is a basic mechanism. So task is object to run the activity in Snowflake at specified time. So this is this task is native to the Snowflake. Okay, so but when you wanted to run this job using Autosys, so that is a different tool. It's a third-party tool. Okay, but task is native to the Snowflake. Okay, there are how many ways we can schedule this job? You know, say in this job, I am trying to insert only one record for simplicity, for demo purpose. Okay, how many ways I can do? I can use either general schedule or cron style schedule. There are 2 ways you can schedule your work. So there are 2 ways you can schedule your work. One is general schedule, another is a cron style schedule. Okay, you put both of them as part of your task. Okay, so this is a command to create a task. So I'm creating a task. So let me use putty for this. So I have saved session. So EC2 user. Okay, let us connect. Okay. Better I go to the use role admin console I use. Usually these kind of activities are done by the account admin. So I'm going to the account admin. In the account admin, okay, I'm going to create one task. So create a very simple, create a replace task, the task name. So you should follow this standard. Use a warehouse. What is your warehouse? Okay. So what is your schedule time? So I wanted to run this SQL query every minute. Okay. When this condition is met, so this condition is always true, right? I'm just using a true condition. Create or replace a task. The task is used to run a statement. That statement is run by this warehouse in this schedule when this condition is met. So this is a style of creating it. Before that, let me check the data in this table. Do I have any data over here or not? Select star from customer TG. Yeah, there is one record available. Let me truncate it. Okay, first I run this statement orally, whether it is correct or not. I'm just validating this insert statement. Okay, oh, already I have done something from background. Okay, so this is a valid record. So I'm truncating. By this time, our table is empty. Okay, what is expectation? Every minute, so this record has to be inserted. Okay, let me create the task. Okay, so see the task is successfully created. What is the life cycle as per the life cycle of task? So task is created and it is not active usually. So it is in a resume state. Sorry, it's in a suspended state. So you need to resume the task. How do you resume the task? Task is suspended state by default. You should use account role to resume for the task. So this is how you resume. This is the task I created, right? Okay, resume it. I resumed it this time. Statement executed successfully. So now let us see. So after 1 minute, we go and see. Okay, so if you are using non-account, so for example, in a case when you are running a task with non-account admin role, you know, right? So provide access to that grant user or grant access. You know the grant statements, right? Using the grant statement, you give that. Okay. Now to check the tasks, this is a statement. Okay. Select star from table function. Already some time back, you have seen this table function, right? This table function is used to write a query on a table or to fetch a data from the table. Okay. So sorry, to fetch the data from this DB and put it as a tabular format. So these many are there. Okay, task C, task 5, many are there. So I created some other. At what times also I'll come back later, but this is just remember this command. Okay, select star from the table of, so database name and this one. Okay, your task history, it will give you the task. Okay, so now let me go and see the data in the table. Ideally, record should be inserted. It inserted, right? So it will continuously run. For every minute it will run. Every minute, so it will keep run and run and run and run. So that is what given by the system. Okay, let me run this again. See, 7 rows this time. Last time 6 rows. Correct. So 7 rows. Or you can see this query in the. If you are confused here, you can see it in the web UI also. Okay, are you at account admin role? Select tables of very strange. Let me say this, switch to system. Am I running correctly? It is running here, or it is not reflecting. Again, 8 rows, 7 rows. Okay, let me figure out that issue. That's not a problem. Here we are seeing. So, and also let's check the table. There should be 2 rows. Right. So, same record is keep inserted because my time is only 1 minute. So, I'm going to suspend it. Okay, how do you suspend? Alter, table name, suspend. Okay, suspend is the one. Now I'm just stopping this. Otherwise, it will keep run and keep execute. So you should be careful. Once you schedule it, okay, that's it. It is out of your hand. So what is your feed here? Okay, so how do you say that this is the time I need to load? It's all depend upon your business need. Okay, again I say simple answer. So they only show your source system or business is aware about your data availability, right? So when they wanted to load the data, okay, it's all based on the business case study. So your model will help you. So as I told you, we have a Snowflake model and dimensional. I mean Snowflake model or star dimensional models are there, right? So in that model, so based on the data availability time, okay, you will do that. Okay, for example, 2 a.m. 10 tables are, assume 50 tables in your project. So 2 a.m. 10 tables, 3 a.m. 40 tables. Oh, you have like that, right? So you need to create your task accordingly. So this is a one way of understanding the task. And second role would be cron style. How many of you are aware about a cron style? We don't know. So this cron style takes 5 parameters. Okay. So in your cron style, first you need to understand what are you doing now. So you are taking a query and you are running at a specific time. Okay, this is 1 minute, for example. Say there are some scenarios you wanted to run the query at 2 a.m. only or only one time in a day. Or so daily you need to run at 2 a.m. or you want to run for 365 days. There are some conditions available, right? So cron style will help you do that activity. Okay. Even you can frame this general schedule as per that also, but best way is a cron. It's the most popular way of scheduling the jobs from the EC2. Okay, or Snowflake is adapting that. Okay, it has 5 stars in it. Okay, 5 parameters. I cannot say stars. 5 parameters. So these parameters are fixed parameters. Like you should not change the meaning of it. So first one is the minutes. Its value is 0 to 59. The second one is the hours. So 0 to 23. So third parameter is a month, 1 to 13. Okay. So fourth parameter is a, so third parameter is day, fourth parameter is month. So 1 to 12, or you can use mnemonics also, January, Jan, February, FEB. You can use, or you use the numbers also. Fourth one is day. Okay. So again, in order to run, there is a problem. So timestamps are different from region to region, right? You know, so 8:30 a.m. in IST would be a different time in your US. So timing would be different in Asia Pacific and will be different in UK, right? You should know where is your Snowflake is launched. That is very important. So you are actually scheduling using Snowflake native tasks, Snowflake native concept, that is task. So you should know your time. How do you know your Snowflake launching place? So where it is launched, we don't know the time. So here it is, IST time is 8:30, but Snowflake, what is the Snowflake time? Let us see this. This is the time. Okay, maybe it's a PST or UST, I don't know. So 22:11, it's 06:55. Okay, this is the time where Snowflake is working. Okay, you should pass this time to the current time. So that's why first select your current timestamp using select current timestamp function. This function will give you that. Based on this, I am actually running the same command using the cron style. The same command using cron style. First, let me truncate the table. I'm truncating the table. Okay, and see the data. There are no records in it. Okay, now let me prepare one cron style one. Task underscore C is my cron style one. Okay, this is the syntax. So provide your warehouse and schedule is equal to using cron. These two are the two statements you need to remember. And what is the time now? It's 06:55, right? So on what day? Okay, first one is a minute. At what minute I wanted to do? So let me run one more time. Current timestamp. So it's 6 minutes 57 seconds, right? 6 minutes 57 seconds. So first one is a minute. So I'll give 8 minutes. Hours is 8 or what is that? Hours is 6, sorry. Hours is 06. Okay. So I'm creating a scheduler for running at okay, 06:57, right? Let me give it a 59. 59th minute, 6th hour, and day of the month means daily. If you mention star, that is nothing but daily. So day of the month. If you mention star in month, every month. Okay, that's what I'm saying. And also week is Wednesday. So day is Wednesday. So yeah. And this is the one you need to mention because why I'm using America, Los Angeles, you know. So this time is usually American time. That's why I'm using it. If you are working in Singapore, you need to do that. And your timestamp input format is this one. So this is a default one. You can do it for anywhere. So it's a 24 hours time. I am scheduling for 24 hours timestamp, not for 12 timestamp. Okay. So okay, already okay. So let me create a scheduler. Schedule. So again, resume it. Okay, where is the resume? So use it. So resume. I don't know. So I just given the time. So I just resumed. Okay, will it be record inserted or not? Let me see. No, not happened. Let me schedule for different time then. Now see the current timestamp. 06:59, right? Still, let's wait for a minute. No, it did not happen. I'll schedule for different time. So I schedule for 071. 07 hours, 1 minute, right? So first one is minute and hours are 07. Okay. Let me take it. I'm replacing the old scheduler. Yes. Okay, again resume. Okay, you want to see the state of this one? You can see this history as well. Where is that history command? Yeah. Here we see is it in a suspended state or ideal state. This one, okay, is scheduled, right? At what time? 071, 11/1/2011. That is the time, right? Okay. So scheduled at this time. Okay, let us see what will happen. Okay, these are the different ways we can do. So using cron tab, you can schedule at different times. Okay, so all you need to know is this one. Okay, you can not only within this cron is not only meant for the Snowflake, it is a Unix capability. Okay, so you can schedule any task like this. So you can study anywhere in the Google and you can do. Okay, So yesterday somebody was asking, right? Can we schedule it? Yeah, we can try and schedule here. So you can create one SQL. You can just take assignment like you are creating this SQL file, right? Save all your queries in a SQL. Okay. And do exercise for pass the SQL to this task. Okay. Here I have given one line, right? You try passing a SQL file to it. Okay. That's where is the SQL file is available. That SQL file will be available in the local Unix box where you logged in with EC2 user, right? So there you will keep that file. That is how our environment is. I'll tell you my environment now. Now you will clearly understand my environment. First, let me see the data. The scheduler is running. Right, the scheduler is running. It ran. Okay. So record is inserted. All right. Now let us understand more about the scheduler. Okay. What I am trying to help you here is how is my environment? How is my project? That may help you. My project is this one. I have data from different regions. So I have 10 tables from one region. Usually UK region, 10 tables are coming. My client is, don't be, okay, so getting bored. Just I'm trying to help you give the flow of the project I'm trying. So in the USA and 3 regions I'm getting the data. So 10, for simplicity, I'm taking 10 tables, 5 tables and 3 tables. Okay. 3 different vendors for me, 3 different data providers. Okay. What I'll do, for these 10 tables, for each table are depend upon the need. I create a single SQL file, run.sql. So this SQL file holding the copy commands actually. So copy command. Okay, run.sql is my command, copy command. So this run.sql, what I'll do, I'll give it to the scheduler name called as autosys. Okay. So, but autosys will not take the SQL directly. What I am doing now, this autosys again, I am putting under one more shell program, or say for simplicity, you can say it as a run.py Python program I'm giving. So this SQL file is executed by run.py. You need to find a proper Python code to run the SQL. This py will be given to the autosys. Autosys will schedule it. So how autosys will schedule? So autosys command is like this: Python create run.py. To this particular program, I pass some parameters. What are the parameters? DB, schema, warehouse. All the parameters I pass. So by the time when I'm running py, so I'll pass all these things. So DB, schema, warehouse. So this is my first step. Autosys is the first step. He is a guy. He will on the switch at 3 a.m. My loads are at 3 a.m. So then Python program will be started. When Python program started, this SQL will be running. When this SQL is running, the copy command will be working. When copy command is working, so the data will be loaded. Why these many steps means? So architecture is happy with the steps. Business is happy. What else we need? Okay, so this is how the project is. But I am not using the task here. So I am using the autosys. What is the advantage? The advantage would be not all jobs run at 3 a.m. There are some jobs. So Asia Pacific jobs, APAC jobs. These jobs, say I'm taking 2 tables for simplicity. This APAC job, okay, is using the few tables loaded by the UK, US, Australia. So this is running at 4 a.m. These 3 are 3 a.m. only. But this guy is giving the data at 4 a.m. Okay, that's why I am going to use the same Python program, but scheduled with the different parameters. I'll have one more SQL, say run 1.sql. this Python program will run this. I am actually segregating flagging accordingly. So that is my own programming style. It's a huge stuff. It's not as simple as I'm explaining here. So all of this, where are these 10, all this, how these 10 tables are coming up, you know, they keep in S3 bucket, these tables data, right? They are giving in the form of a files. So they give 10 files. My system is completely file system. So they put it in S3 bucket. Okay. So S3 bucket is, I load all my copy commands will read the data from S3 bucket at 5 a.m. actually. At 5 a.m. I remove all the files from S3 bucket. I mean, I'll archive them. So this is that. So make use of S3 bucket temporarily. So once your job is done, then again you put back the files into S3. Clear? So this is how my program is being scheduled. I'm giving very in simple terms. This is how it is, right? So you have a lot of material available, so you can go back to the scheduler. I mean, you find a lot of material in your help document for tasks, crans. You can understand all of them. Okay. So any doubt in this? Any doubt so far in flag in understanding the cran style or in understanding the tasks? Yesterday, one of our students raised a question. I think he is clear with that. Okay, so no other questions, miss? Yeah. So we go to one of the very important topic with respect to the examination. Okay, so this is fully theory, guys.
Yeah, hello,
Yeah.
Raghav.
Yeah, please.
Can you hear me? Yeah, I have a question. Instead of using that scheduler that they schedule the tasks, we can combine it with Snowpipe because that will also do the same kind of job, the continuous ingestion.
But Snowpipe, you cannot give a specific time actually. Say you wanted to schedule at 3 a.m. exclusively.
Okay. Okay.
So you should ask your source team to keep the file at 3 a.m. only. So, so that is the disadvantage. It's a continuously, right? Snowpipe is like a continuously watching it. It's a trigger who is continuously watching for the data. And also, if your location is a database, for example, you are reading from the database.
Okay.
In that case, you prepare your own SQLs, right? Okay. So as of now, we are working with files. In case your data provider is in the form of a database, so that's a different approach. So at any cost, so we should be end up with the scheduler separately.
Okay, so it means schedulers is for if you want to secure the particular jobs.
Schedule it at a particular time.
Okay.
It's not related to the security.
Okay. Thank you.
No, thanks. Yeah. Yeah, please.
Yeah, I have a query with the stream. When yesterday when I was working with the streams, it was like I could see the insert update in the insert is the metadata action, but not the update or delete. Streams is not capturing either the update or the delete. I'm just seeing only the insert thing.
You are not seeing delete?
Yeah. Even if I delete something from my source table, that is not popping up in my stream.
If you delete from the source table, it's not marked as a delete, you are saying, right?
Yeah.
It should be marking as a delete and update will be no. Please share your screen. Probably once this security class is completed, we spend our last 10 minutes and we see that problem.
Okay, sure.
Okay, thanks. Yeah. Oh, this is one more important concept with respect to certification. It is completely theory, guys. So, but interesting thing. It's all about us secure how Snowflake is giving the security. So before that, I would like to give some assumption like how Snowflake is organizing the data. Okay, I will give you a simple slide. Okay, just understand it. Okay, from this slide also you will be getting 1 or 2 certification questions. Okay. 3 things you need to understand here. First thing is micro partition. The second concept is physical storage. Okay. Third concept is clustering. Okay. So coming to the DB, other DBs, the storage is in the form of where do you store? Usually you will be storing either in a cloud or on-premise, whatever it is, you will have a reference for your storage. Reference means, say I'm loading this table. For example, this is let's take a Oracle case. Same customer ID, customer name. Okay, say two customers, A, B, 2 R. What will happen, when a table is getting created, so this Oracle engine will create an index for that. Say ID index 1, index 2, it will create indexes like this. So for example, when I'm running a select star from this table, your database engine will go to index, then it will go to the location and pick it up. Okay, so extra time is given for the indexing. Okay, if I use a query where customer ID is equal to 2, so you are giving the data, so the Oracle engine will spend some time to find the index first, then it will go to the data. So this problem is completely resolved in the Snowflake. Okay, so there are no indexing concept available. Okay, so how the data will be organized, let us take like this. No indexes. One point I would like to give a note. Okay, so entire data is a physical storage. So this complete is a physical, no indexing. Okay, so this is a physical storage. You call it as a physical storage. What is the meaning of physical storage? So straight away you can open your door and take your food. That's it. So Snowflake is also working. It will straight away go to the location and it will pick the data when you are running the select statement. That's why the Snowflake processing is very faster. To do that activity, Snowflake takes the help of micro partition and it will organize the data in a columnar format. Okay, see this example. This is my source data. Okay, so can you see type, name, country, date, sort of records are there. So type 2, its name is C, for example, country is SP and date is this one. This is a file assume or anything, any logical structure. It could be a file or it could be a table from other place, whatever it is. This is a data we are feeding to the Snowflake. How Snowflake will do, it will read a column and break the column into multiple partitions. That is completely Snowflake's responsibility. See, initially it has 4 partitions it has given. Okay, depend on the data, it will do the partition. Okay, so see, 4 partitions are created. First, it read a column 2, 4, 3 organized, right? Then 2, 4, 3. After that, 2, 3, 2. See, 2, 3, 2. Okay, after that, 4, 5, 1. After that, I think 2, 3, 2, right? 3, 2, 4. So it will fill one partition, then it will go to next partition, then it will go to another part. It will fill like that. Then again, it will take one more column and it arrange. One more column till the partition is full. It will arrange the data. Okay, this is called as a micro partitioning concept. This is how internally it works. You will not see that actually. The same data. When the query is being run, so when you want to select the data, it will go to the partition location directly and pick it up. That's how it would be. Say when I say select star from this table where type is equal to 4. So it will go to 4 directly and it will take this data. Correct. It will go to one partition and pick it up. So at any point of time, so it will go to partition and again column is taken and distributed. Selection time also column is taken. That's why Snowflake is called as a column level data organization tool. Okay, so that is the very first question in our certification. And also, if you face some interviews, so many people will ask, what is the difference between traditional database to Snowflake as a database? So it supports there are no indexing. The second difference is, so it supports a micro partition. So data will be organized in the form of columns. But what is this partition size? Usually it is a 500 MB. Okay, so That's what he's saying. Micro partitions are physical data files that compress the Snowflake. Again, this is compressed data. Okay. Snowflake automatically partition the data. So you are not mentioning the partition. So there is no headache of a partition. Okay. Being a user, there is no headache of partition. You don't say that, hey, do this like this. But you cannot say that there is no partition. So headache is, there is no headache for user partition. Okay. So on the data, again, so it's a purging. So the user no need to be define a partition schema. Automatic micro partition avoids between these partitions. So you believe me or not, if you are already working in ATL, partitioning is like a nightmare to us. Okay, we need to take a lot of stuff. So whether partition, all these things. So all the partitions are immutable and 500 MB. So okay, this is all about the stuff. Just I understand this picture and make sure that so your Snowflake is reading your data in a column format. In your sense, it's a rows, but it reads in a data in a columnar format and organizes in a column format using the micro partition. Okay, so next I jump to a concept called as a security. Again, go back to the architecture. How Snowflake is giving the security to your so many things. Okay, so lot of things are there to secure, right? Can you give what are the objects we have discussed so far? We have discussed about shares, so secure views, tasks, tables, right? And also we have created streams. Okay, we have created streams, right? So many we have created so far, and we have introduced the roles. We have introduced the users and lot of stages. So internal stage, external stages are there, pipes are there, and also file formats are there. So many objects are there, right? Everywhere you need a security. Correct. Snowflake is best in security, and it divides the security into 7 types. So one is a access security, next is a role security, so multi-factor authentication, and also data is encrypted and decrypted, right? So everywhere Snowflake is compressing the data, so data encryption. When you are actually transferring the data across different regions, from AWS to Google Cloud, or from AWS within AWS same region, within a cloud same region. So then network policies. Okay, and also everywhere you need to take a government permission for the data, right? Single sign-on, and these are the things. Okay, first let us understand the access control. First of all, one fundamental point is Snowflake is secure by design. What is the meaning of secure by design? Let me give a simple example. You are building a car, so or you are manufacturing a car. By the time when you are actually fitting a wheel, you are giving 3-layer protection to the wheel. Right. That is, by the time you are designing, you are using it. At the end of the product, you are not actually giving security to the wheel. Okay, when you are actually working with the what do you call fast controller, when you are building a fast controller, you are actually adding a airbags to that automatic. So it's a design is secured, not a product is secured. Okay, this is a very important statement. Will be coming up again and again when you are working in a UAT or production environment. Snowflake is secure by design. It's a software as a service and it is secure by design. Okay, so what are the things secure during the design means all your components. Okay, authentication. So authentication, access control, data encryption. So these are the 4 parts are considered as a part of a Snowflake design. Authentication means how you are logging in into the system, right? So access control means say admin account has a access control on the shares, but sysadmin will not have. How is that possible? So based on a role, right? So data encryption. So data is every time encrypted, purged, and loaded in the micro partition. And when data is coming out, again it is decrypted and okay, unzip to the user, right? So any external validations, right? So there are some other certified vendors wanted to access your Snowflake. So that is the one. What is the example is, say you are building a Snowflake for the banking application. So some credit card data is completely external to that. So it has a separate access control mechanism for the external data. For example, SSN data is a very common data, right? So for that, Snowflake is giving extra protection for that. Okay, for few data items, you want to protect separately, protect it. Okay, that is available, and also it's secure by design. So here the points are authentication, how authentication is given, access control, data encryption. We try to understand. Okay, coming back to authentication. Authentication is nothing but I'm logging in here, right? I'm logging in using my Snowflake user ID, and I'm securely connecting to the HTTP protocol. So using our Snowflake computing capability in a region. Okay, how is that possible? You know, usually in real time you will have a MFA, multi-factor authentication. All of you are aware about what is MFA now. So many ways of MFA, right? One example, you are doing a bank transaction, you will get OTP, right? That is MFA. That is a form of same kind of MFA you can put up in the Snowflake also. So it's completely theory, guys, because I cannot show you in the demo. It's when you are working, you see that. So multi-factor authentication is there. Okay, so how this multi-factor authentication is? There are three ways. One is you can install a separate tool called as a DUO tool, DUO app. You can install DUO app. Is a web-based app or a personal app. You can put it in your computer, or you can put it in a laptop. Sorry, you can put it in your mobile also. So one way is you will have a separate app installed in your mobile. Okay, and another way is you can get a call also. Every time you are logging in, Snowflake will call you. Hey, are you, say, X person is logging in, are you X or not? Okay, so he will get that kind of call confirmation and a passcode also. So every time you will get a passcode to your mobile or passcode to your email. Three kind of ways you will be used for the multi-factor authentication. Login into Snowflake. See the guy, Mr. John entered his Snowflake details. So after that, he choose one of this mechanism. So assume that DO push. So push will be coming to your mobile. He'll push it and or he'll call a phone or whatever it is. So finally, his login is successful. If you forgot MFA, or if you forgot, if you uninstall that DO app, or if you change a mobile number, it's your responsibility to give back to your Snowflake person who created your user. Who is the person here? Account admin. So one of your team member is account admin. He is responsible for MFA. Okay, so during the time of MFA, you are actually going to a different channel. So you may ask a question, yeah, I am working in Snowflake, why mobile is coming to the picture, right? Because that is the most secure way people are feeling now. When you are working with mobile, again, you need to work with some federal companies, right? So making sure that, so those are some key points you need to remember. So MFA is a multi-factor authentication. Okay, MFA is provided by the DUO services. That is a different service vendor, right? So Snowflake has collaborated with this DUO company. Once MFA is installed, DUO you should install this. Okay, each user must enable MFA by himself. Say there are 100 people, so client is also using your project. When client is also using the Snowflake account, he is also not an exemption for this. So all developers, account admins, everybody should enable MFA. All users with account admin role should have MFA. So you may feel that account admin is a super user, but no, he also part of the MFA. Okay, so see, you know SSO, single sign-on. Okay, allows user to access, say, what is this SSO, right? Let me give like this. User A is a user. For example, let me take John in this case. So John working with the DUO app. Okay, so finally, once this DUO is green, then you will log in into Snowflake. So this is a kind of mechanism, right? So how this DUO, this is a separate app, right? How this app is validated from the Snowflake end, you know, they use SSO mechanism. SSO is a popular mechanism. You might have heard it. So Snowflake has a separate mechanism called as SSO, single sign-on. Using the single sign-on method, so Snowflake will validate is it correct or not. So for that, Snowflake guys is taking a federated service itself. Usually it is called as a IDP. Okay, identity provider. This IDP is a part of your cloud actually. So this IDP is from cloud. So Snowflake make use of the IDP provider in the cloud. Okay, you will see this IDP anywhere in the Google Cloud or AWS. Okay, so and it follows the single sign-on approach, SSO approach. So IDP is a federated service, it's a government kind of services. So SSO with IDP allows DO security to authenticate the user. Okay, so as long as this IDP session active, they can access Snowflake. So your client, our cloud guy should enable this. Okay, it's IDP, not IPD. So, and one more thing is this SSO or whatever the security will be available from Enterprise Edition and above. Okay, so you can at any point of time. So for all users, MFA can be disabled by the account admin. Okay, so say this is about multi-factor authentication. You are getting right. So is implemented by security is by the DO service. So everybody should be understanding it. But SSO with IDP contacts the federated service, and it is from Enterprise Edition Plus. Okay. What is MFA? Again, he is giving some more details. The self-enroll process can be done by others. It can be disabled permanently by the account admin. So by using this, account admin will use these two: disable MFA true means to bypass MFA 5. So these are the this is one way he can disable the user. Say your account admin, you created a user, so then you are responsible for his MFA. So you can disable like this. Okay. Different user can send a single sign-on. 11th part, this tricky point. The point is, I can say like this. So there are 5 people in the project. For all the 5 people, they will use a single member. Okay, single member, single token actually. So if you open this Snowflake application, what is my role? What is my role is a sysadmin. This sysadmin is given to all of you guys in the project. Okay. At the same time, you all are given to the DEO tool. In the DEO tool, you all will be given for the same number to be. What is the DEO tool? Right? In the DEO tool, you enter some numbers, passcode like that. That passcode is common usually. So say there are many people. For all the people, you enter the same passcode because you all will be following the same rule. That is not a security violation. Usually companies are following that. That's what it's optional. Okay, I mean it's important. Many companies are following, but it's optional. Okay, so you wanted to give a different RSA token to the different people, not a problem. So you can see that actually when you are working. So my number is a common. I have 5 people in my project. All 5 people are using the same passcode for the DO security. Okay, so MFA is one of the authentication mechanism. Okay, so what are the objects you need to secure here? Okay, anyways, now you got access and you are clear that during the login time you should be enabled with the MFA. Now, what are the various objects to be secured? These are the different objects: users, roles, warehouses. Sorry, this is not so clear. I'll try to tell that. So users, roles, warehouses, resource monitor, integration, database, schema, tables, external tables, view, stored procedure, sequence, stage, file format, pipe, stream. These are the various objects to be secured. How these are secured? All objects are controlled by a security mechanism called as a DAC or RBAC. So DAC is discretion access control mechanism, role-based access control mechanism. Okay, usually 2 access mechanisms, okay, 2 security mechanisms for the objects. Okay, so Snowflake combines DAC and RBAC for securing all your objects. So we have secured the user. Now we are thinking about objects inside it. DAC handles the ownership. Each object has a owner and has a full object. Okay. So RBAC handles the other access except ownership like object privilege and roller. So what is trying to say? Say now account admin has complete control on the, say take our shares case. Account admin has complete control on the user roles, right? So that is DAC. Okay. Whatever the particular user role has created a lot of objects, right? Those will be controlled by the RBAC. So ownership and objects. So ownership is under DAC Object security is under RBAC. Okay, so this is the hybrid model, it is working. So all the objects are secured like that. So that's why whenever you are switching the roles, you see different access mechanism. Same. Again, same topic we discussed, right? So here, this will be helping you to understand the roles. Okay, let us take a table. Okay, a table and a warehouse. The symbol is a warehouse, right? Here we have table A, table B, and warehouse 1, warehouse 2. How these are objects are secured? First, roles will be created. We were discussing clearly during the secure use. First role will be created. That role will be assigned to the users. So role 1 is created. This role 1 has view access on X and Y are the tables. A and B are the warehouses. Okay, X, Y tables, A, B are the warehouses. So this table, this role 1 has only read access on X and Y, and it uses only warehouse A. Role 2, it has a read access on Y and write access on Y, and it can access B only. Then the users will be given. So role 1 given to user 1 and 2, role 2 given to 2 and 3. Role 2, user 2 holding role 1 and role 2 access. This is how you need to build. So day 1 you start a project, you create all the objects, right? Then you start creating the roles. Best approach is first you create roles, then you create users. After that, create the tables, then put a security. Okay, this is all admin account or user admin roles and responsibilities. Okay, finally, so all you need to remember as per the security perspective is all objects are secured by the DAC and RBAC. All objects are maintained through the roles and users. Okay, so what about data security? When there is a data in a table, how that is secured? Okay, so logs, how that logs are secured, right? Lot of logs you are seeing, right? You see a history. I'll tell you history. So this is nothing but logs only, right? So how the logs are secured? How encryption at rest, encryption at motion. So means when you are accessing the data from physical storage, that is encryption. But when you are moving the data over different cloud or within a cloud, different region, or between the shares, whatever it is, at motion. The data security, all data is encrypted by AES 256 encryption algorithm. So if somebody is from the network securities background, they know this AES 256. Okay, so this is a encryption, and you know, right? We have seen the staging yesterday. Inside the staging, all are files only. Correct. So your stage, either it is a Snowflake managed stage or external stage, there is a files only. Okay, there are files only. So that will be secured by any of this. AES 256 or 128. So if you choose 256, it covers 128 also. Okay, so special edition of Snowflake allows periodic rekey and customer. See, you have a different edition, right? Standard edition, enterprise edition, virtual special edition. So in new edition, they are not actually taking this security algorithm. So periodic rekey, you need to remember this. Data security in the special edition is under the control of periodic rekey. So connectivity. So I mean, again, along with MFA, when you are connecting, so it uses HTTP protocol, or for communication purpose, it uses this TLS 152. These are the protocol for transmission, right? You know, right? TLS protocol. This is a very common protocol for our internet also. Okay, activities log, history tab. You have history tab, all right. So all are the history commands. History tab provides all history commands. All details included in the session ID can be viewed. Each query has a query ID. So how this log is secured means one through the history tab, right? Open a history, you get log, right? And session ID will tell you a session, right? This is a query ID will tell you a query. Session ID will tell you how long your session is active, right? So that is actually activity log is controlled by history and query ID and session ID. So login history will be controlled by the same. So login history family of table function can use a query log, all the information schema tables. One more point is query history is available for 7 point. This is what I is trying to say. Now, what is the date today? So date is start time 8:50. Okay, 11:16. 11:16 is the last one, probably. So continue search. You will see only 7 days. Last is 10th, I think 11:10. Before 11:10 we cannot see. Oh, still 8 is there. I think this edition might be there. Let me correct this document. As far as I know, it's 14 days, but 7 days is written. Okay, so for history, you can get this number from the help document also, not a problem. Or else let me search here for surety. Help document. So query history. Query history. This account details can be viewed by query history within the last. Oh my God, 365 days. Yeah, I need to be updated. Right, so 365 days query history it is saying. Very good. So this is the old document, guys. Okay, so any infrastructure monitoring, so threatened stack sumo logic. We no need to worry about all this logic. Remember the names. So data security by this algorithm. So files in the stage are by this algorithm AES 256. So connectivity and application log is secured by history tab. So this is the thing. This is a small example for rest and motion. Okay, in rest, this is a security, and in motion, so these protocols will be securing. So you can see this. So end-to-end encryption. So encryption algorithms I'm trying to give, right? It's okay. So data files are there, and you will be putting after encrypting. So it will go to the stage area and encrypted and loaded into the database, or you can same encryption applies in the database. Next is the network security. So how network is secured, right? So protocol is for just for establishing communication security only. Okay, through the network when packets are moved. So this is the one network policy. You need to create the. I mean, usually this will be created by the cloud guys. Okay, so they will take help. This is copied from the cloud only. Okay, network policy security. You need to whitelist your IPs. Okay, in which network you are actually transferring, that a whitelisting you will do. You will use a private link, private communication. So I think you can read it, not a problem. So this is completely a cloud based thing. So all I need to say is you will be whitelisting it. That's it. Okay, your IPs will be whitelisted by the cloud guy. That is a very important point here. And also network policy will be created. So I mean, what is the policy? Really, I am also not sure. But so the policy is not given to us actually in my company also. So there is a policy established. Okay, so this is a way. Actually, this diagram is interesting. Okay, what is this diagram? You know, what is happening? You are actually giving a set of data to Snowflake, and it is encrypting the data and decrypting when you are reading back. By the time when micro partitions are created and data is loaded in the micro partition, it's encrypted. There are 10 different buckets. So data is keyed up and loaded. When you are reading from the bucket, so unkeyed, right, and locked. So there are two ways that keys are managed. Okay, so the two ways that encryption is organized. First is hierarchical key and key rotation. Okay, don't get deep into this. So this is a data. For each partition, you will have a key. So those keys are actually combined as a one more key like this. So it follows a tree-based structure. Okay, for the keys. So child keys are actually secured by the parent key. So these three are child keys secured by this parent, and these two are a child keys secured by this parent, and finally two keys are there. So hierarchical keys is a one way, and key rotation means what they will do, you know. So they save the keys and they rotate it. Even I'm also not so confident about it, but these are the two mechanisms. Automatically, this keys rotation and this is organized by the design itself. Okay, because they created the own what is that, to organize all these things. Snowflake use the JavaScript. If anyone are from JavaScript background, so this entire web UI, whatever the view you are seeing, right? So this statement all are actually used a programming language called as a JavaScript. Okay, so I mean I repeated this for security. Okay, so it's a policy, and these are some security policies. I told you about creating policies, right? These are the HIPAA, PCA, NIST, SOC. So these are some policies. Okay, usually I say a questions like any question will use only one policy. Okay, they will not confuse you between I haven't seen a question like having options like all of them. Okay, so these are the policy names. Okay, so quick summary: you need to have a network secured, and account secured, user secured, object security. Okay, and data security. So by using this, so these are some validations. Okay, it's a purely security theory. All you need to understand, I mean, just remember few names. I can say minimum 5 questions from this uh, document. Okay, you will have like MFA 2-3 questions are there, and data security. So refer this table. It will help you a lot. Okay, I cannot show any hands-on on the security because it's not in the user control. Okay, so it's all in the some only MFA this guy can do. So admin account can do, remaining all are not in our hand. Okay, so this is completely theory. Go through that. Any questions, please ask me. And okay, I've given the micro partition, right? Did I create sequence here anywhere? Okay, so one small concept is sequence. All right. Yeah, so somebody was asking me issue in the streams, right? Can you please share your screen?
Yeah.
Yeah, wait, let me make a presenter. Wait, I'm making a presenter.
So are you able to see the screen?
Can you show me the stream now?
Yeah. So this is the screen which I created.
Don't create now. Oh, it's just created. Oh, yeah,
Okay.
empty stream. No problem. Can you insert record?
Let me first the CV data and my source already there. I'll just truncate it.
Just truncate source table.
Okay.
Now insert it. Okay. Let us see the screen.
So if I run that, it's something.
So you deleted 2 records. It is showing as a delete and update false, right? Last.
Okay.
Delete is a deleted one. You truncated and deleted, right? So
yeah,
it's false.
Okay. So, but the thing is, for example, if I update this,
after update also, it will be treated as a delete. Update is true.
It is not showing that. It's just straight away updating the value. Like my previous value was same and which has been updated to Berkshire. It's not showing like the previous value has been deleted and the new value has been updated.
Can you update location name to different name? So yeah.
Maybe I will have something like
same, give like no, copy the name. Yeah. No. You are updating that. Control Z.
No.
Control Z. Okay. Berkshire update to the Berkshire 1.
Okay.
You have copied the same value, right? Okay. Just update it. So you are updating location source. Okay. Record is updated. Now see the stream. See this Berkshire 1. Okay. See old one. Okay. Update is treated as, what is the old value for this?
The old value was
Update.
Berkshire and the new value is Berkshire 1. And it's
Mhm.
only just showing me the insert.
Mhm. So it should be delete and insert.
Yeah. And even the update is showing as false.
Okay, update is showing as a false. Can you show me the stream creation statement?
Yeah.
LOC source, right? Scroll down. LOC underscore source.
So
The table.
this is how I created the table.
Can you show me the LOC source? I mean, after update.
Okay.
Location. So this Berkshire 1 has to be updated as a delete plus insert. It has to happen.
Yeah.
Can you recreate stream once again? Just
We'll drop this one.
create replace. Use replace. Create. No. Create replace. Same stream. Create or replace. Yeah. LOC stream or location source.
We'll have to.
Can you select that statement alone?
Sorry.
Can you select that statement alone?
This one?
Yeah. Okay, stream successfully created. Let us see the stream. Yeah. Location stream 1. Okay, now data. Now insert the data. I mean, you have can you truncate the source also? I mean, let me confirm. Truncate LOC source. Okay. Insert now. You have two records.
Yeah. Yeah. Now I'm gonna insert this. Yeah.
Now see the stream. Yeah, see both the things.
So your values have been updated.
Okay.
And check the stream.
You are creating stream 1 only, right? The problem is your stream is not becoming empty because you are not merging, right? Ideally, the stream should hold the two records only, right? But why your stream is, yeah. So once we can you drop and recreate stream alone? Yeah. You are using okay sysadmin. Okay. Now see the stream. Let's create a stream.
Yeah.
Okay. Now insert. Just truncate the source and insert one more time. Okay. Insert it. Now see the streams. Why are you dropping correct stream?
Yeah.
Your stream, once you drop a stream, you should not show that. Can you merge it? Once you merge, the stream become empty, and we try create one more stream. Have you merged command?
Merge into that somewhere.
Okay, parallel you write merge statement. Other I will take any questions from others?
Raghav, I just able to solve my AWS issue and now start working on Snowpipe.
No problem. Yeah.
Yeah.
So probably tomorrow I'll close all this content and we will have 2-3 exercises from day after tomorrow. Only one more topic pending. That is called as a clustering. Actually, the point is Snowflake has taken care a lot of things, right? So our curriculum also become very small.
But there are a lot of very minute things that we have to follow. I mean, there are a lot of small steps in every topic, and just like in Snowpipe, just creating the stage while loading the data. So it's quite difficult to remember all the steps. Small steps are there.
Yeah, that's why we do two kind of small assignments, and we will download the data from the information schema, Snowflake standard schema, and we try create. So margin to location target as a T using select star from stream where not passed. Location number is equal to location number. And that then update. You cannot, you don't need to use it. Okay, so then insert values. Okay, so we're taking from. Okay, can you merge it?
Can I run it?
Yeah, let's see. Expected. So merge select. Can you let's balance the things. Working with,
Okay, I made a mistake.
SQL line 3, position 58. Margin to table. Using select star from S. Yes. I'm saying, I think you need to use the casting. Can you see the, okay, you have taken the casting as it is, right?
Yeah.
Can you cast the data types?
I don't want to cast.
Also, this is actually not a problem with casting. So there is a unexpected somewhere extra comma. merge into select star from local string where not matched. Where not. Okay, after where not, there is no, I mean, there is extra word matched in 128th line. So remove matched.
When not.
In 128th line. In 128th. 120 line. No. Control Z.
Okay. Sorry. This one?
Yeah. That one. So logically that's not quite. Yeah. Can you run now? Okay, wait. So syntax error at line 3. So where not as a on cast of this one, then update set t dot local number equal to you have to use, right? So by the time you are setting up, yeah, you have to use the what you are setting. So target to be with the source, right? T dot location is equal to, you are setting t dot location with.
So then update set t dot location is equal to s dot location ID.
Yeah, in this way you have to give for all other values.
Location.
Address D address.
Yeah.
So I believe it is correct now. Location ID. Do we have s dot location ID? Invalid identifier is a location ID. Do you have the location ID or location number on the stream?
I got confused on that.
Not a problem. No. Same. Change at 121 line also. T dot location, fine.
No,
S
like
dot
I
location.
think let me just check my table once again.
Okay,
I
no
think
problem.
in target it is a location number. And then maybe I'll just change my target.
You keep everywhere the location number, location ID. Yeah? Okay.
Yeah.
Target is location ID, source is location number. Am I right?
No, both are location ID.
Okay, wonderful. Yeah, no confusion.
Just to avoid the confusion.
Yeah. Yeah, now let's change the margin. Yeah, everywhere location ID only. Okay, so now let's go to the stream. Let us see the stream. Now records in stream, right?
Yeah.
Okay, so and let's update one.
I can see that. So if I make an update in the
Better copy the data. Yeah, double click. Yeah, copy paste. You are updating the Staines to Berkshire 1.
Yeah.
Okay. See? Actually, what is happening, you know? So from source to stream, how that is happening? Everywhere, I mean, every time, if the, what can I say? So now you updated it, right?
Yeah, it shows true over there. Update.
2 records over there. Yeah, see,
True.
it's yeah, true is fine, but for every updated record, you will be having 2 records actually. Can you observe in the stream? So one record is for insert, that is true. So, and one more is saying that stain is deleted.
Yeah. Yeah,
And,
this was
but
not showing the first time and now it is showing up.
every time you need to merge it, otherwise it will be treated as a duplicate match only. So here source to stream, so match is duplicate, that's why it is not showing you the changes. Also, logically speaking, without merging this to target or somewhere, why are you creating the stream? I mean, that's our question. But usually speaking, so once stream data is available, it should be wiped off every time. Otherwise, it is treating that record as a duplicate for one match. So, and it is rejecting it. In fact, it will not compare the actions, right, with the source. Okay, every time it will compare these values only and then take a decision. So at one point, whatever the record it is coming from your source, as stream is already full, it is treated as a duplicate. Duplicate will reject actually. That's what the happening. So better always empty the stream, then you will get you run the cycle as it is, stream life cycle. Am I convincing you?
Yeah, like I kind of get it. So if I need to have a source, a stream and then a target. So if there's a mismatch between the stream and the target, then it updates it.
That's a merge operation.
Okay.
Now, what do we need to understand is between source to the stream. Okay. So first stream is created. Okay. Assume that that stream is not merged into the target. So, and an update happened at the source. Okay. One of the record is same value, say you updated stains to the Berkshire one. But when stain, already stains record is there in the stream, right? It will treat old stain with the new stain and it reject that source. You got it? So that would be treated as a duplicate record. So stream will recognize the old and new. Okay, right. When it is validating old with new, at one place it encountered a duplicate. That's why that change is not reflected in the stream. Getting me?
Actually, the change is getting reflected. I could see the new value, but the old value is not showing as delete.
Exactly. It won't treat like that.
Okay.
So because it recognizes the old value as well. Getting me? So every time, say now you update one more time and without merging, update Berkshire 1 to different value. So Berkshire 2. Say okay.
Something, some random answer.
Yeah, any value. Now see the stream. Do you see Bharat? So what happened to that? But why Berkshire 1 is not there?
The old value has been
replaced actually.
Okay.
So still that was there because it is recognizing that. Okay, so here you need to focus on what's happening between source to the stream. It's not with the stream to the target. It is replacing the old one because it is treating that as a new one, inserted one, right?
Okay.
So follow the cycle every time, you won't get this problem. Stream and merge. So otherwise it will be a problem. You will get some different result.
Okay, thank you.
Good question. Yeah. Any other questions from anybody? Data warehousing past to present. I believe you are clear with this. So key concepts I have given: architecture, additions we have discussed, data life cycle, continuous data production is a Snowpipe, different connection types, right? AWS, all this stuff. Creating account we have created. So tools we have installed, Python we installed. Okay, so Snowpipe we installed. Okay. Any drivers and all, we see JDBC, ODBC drivers are there, we'll come to that. So we have downloaded the sample files also yesterday, right? Look into web interface. So creating virtual warehouse, database schemas, stages, file format, sequence is pending. Okay, loading data from the UI. So again, we have seen the CLI. So JDBC driver is pending. Okay, and loading, unloading. So we have done this using AWS. Azure, I'll tell you. So roles we have created. So this credit uses we have discussed. So materialize view, cloning, time travel, fail safe. So querying data in the staged file. I'll tell this one more time, not a problem. So using notification, Snowpipe we have done with the AWS notification, right? Sharing data shares we have seen. Security is whatever the one today I was saying. Security features, multi-factor authentication. Okay, connection from other applications. So Python we are seeing. Tableau I cannot explain you guys. Even ETL tool is also I cannot explain. These two, it's not possible for me to explain in this place. So yeah, credit users we have discussed. Okay, I think pretty much we are on the track.